So actually what I am telling you, okay, remember this particular thing. You need to remember like this. We'll discuss, don't get nervous, okay. What is the Laplace transform of sine t? Sine t is, if sine, suppose like this, sine at is there, so a divided by s square plus a square. What is the Laplace transform of a cos at? Is s divided by s square plus a square. Okay, now what is the Laplace transform of this function? If you are getting a function like this, it's, if a is there, s plus b the whole square plus a square is there. So what is the Laplace transform of this? Means here some delay is coming, so e power minus bt into, and a divided by, assume like this, a divided by s square plus a square only. So that means what? That means you are getting sine 80 only, but you are not getting s here. B is also there, so you have to write e power minus bt. That is known as a delay function. Okay, if it is like this, s divided by s plus b the whole square plus a square, so what is the meaning? E power minus bt cos 80. Is this clear? Is this formula is clear? Priyanka, is this formula is clear? Sine,
Yes, sir, yeah, clear.
sine 80 is a divided by s square plus a square. Cos 80 is s divided by s square plus a square. We will derive actually now. You don't remember. You don't have to remember this particular formula. We will derive how to get this particular formula. Okay. While I will teach you the Laplace transform. But for now, you just remember these things. Okay, sine 80 is a divided by s square plus a square. Cos 80 is s divided by s square plus a square. And if delay function is coming, so you are getting like this. Okay. So we will derive when I will teach you the Laplace transform. Then I will tell you the how to get the this kind of a formula. But for now, just remember. Okay. So I'm getting this function. So I'm getting like this function. So this function means this is your a, e power minus at sine bt. I am assuming b is my this one. Okay, and 50 is common, so 50 is common. So what I will get? 50 e power minus a is what? A is t, and b is what? B is 1 sine t. So you will get what? 50 e power minus t sine t I of t. Is this clear, Priyanka? Is this clear for you? Is this clear or you?
Yes, sir. Yeah.
Okay. If it is clear, then it's fine. Mm. So now, I have one question. You need to find the current delivered by the source for t greater than 0. So how you will do it? How you will do it? You need to find the, and I have not given you the circuit, so let me give you the circuit first. So now you know they had directly given the circuit like this. They didn't give the switch. They had given the circuit like this. Capacitor and this particular positive negative. This is your e power minus t u of t. What is the meaning? Means from minus infinite to 0, my switch was open. Then this all part was open. From 0 to infinite, it's getting a exponential voltage like this. Okay, and the value it's given as a 5 Henry, and this is 2 farad, and this is your 2 ohm. Okay, overall all initial condition is 0. I of 0 minus is equals to 0, V of 0 minus is equals to 0. So we can directly we can I'm writing this as a my 5. This will become your 5s. Okay, I'm not writing the initial condition minus I of 0 because I of 0 is 0. So what we did in an earlier case, I have written like this, minus Li of 0. Okay, like this. I don't want to write because I know that the initial condition is 0. Okay, and this is directly I am writing 1 by Cs. So 1 by Cs is 1 by 2s, and this will be your 2 ohm. You are getting the circuit like this. And what is the Laplace transform of e power minus t u of t? So I told you u of t Laplace transform is 1 by s, but you are getting one extra term e power minus t. So that's mean what? A delay is coming. So you have to write wherever the s is present, you have to add 1 because our a term is minus 1. So e power minus at into u of t, you will get the Laplace transform is 1 upon s plus 1. Okay, 1 upon s plus 1, you will get this Laplace transform. So if you will convert this particular in like this will be your 1 upon s plus 1, and this is 5, this is 5s, this is 1 by 2s, and this is 2. Solve this particular circuit, and this is in series, this particular is in series, both are in parallel. So you will get Z1 here, you will get Z2 here. So Z1 value will be 2 plus 1 by 2s, and Z2 value will be 5 plus 5s. Right. So if you solve this particular value, what you will get? 4s plus 1 divided by 2s, and this will be 5 plus 5s. And overall Z equivalent will be Z1 Z2 divided by Z1 plus Z2. So Z1 Z2 divided by Z1 plus Z2, what you will get? 4s plus 1 divided by 2s into 5 plus 5s, 5 plus 5s. Okay, do the calculation with me. 5 plus 5s divided by 5 plus 5s, and this will be 4s plus 1, 2s plus 5 plus 5s. So solve the circuit, you are getting something like this, I think. 4s plus 1 into 5 plus 5s divided by 4s plus 1 plus 10s plus 10s square, and 2s will get cancelled out after taking the LCM. So you will get 4s plus 1 into 5 plus 5s divided by 10s square plus 14s plus 1. So this is your Z value, and you need to get the value of I. So I will be what? I will be V of s divided by Z. So your V of s value was 1 upon s plus 1, 1 upon s plus 1, And what is your z value? Z value you are getting particular like this, 4s plus 1 into 5 plus 5s, and this overall value 10s square plus 14s plus 1. Okay, so you are getting like this, 10s square plus 14s plus 1 divided by take 5 common. If you will take 5 common, you are getting s plus 1 the whole square into 4s plus 1, right? You will get like this. Priyanka, up to here you understood what I did?
Yes, sir. Yeah.
So
Can you scroll up the screen?
scroll up. Okay, I will tell you once again. See, I have a circuit particular, this is my circuit. Find the current delivered by the source for t greater than 0. I have 5 ohm resistor, 5 Henry inductor, 2 farad capacitor and 2 ohm resistor. And this e power minus t u of t can be, the Laplace transform of a u of t is 1 by s, and we having a delay function of a 1 second delay function, so this can be converted into 1 by s plus 1. I will discuss you properly, means if you want to find the Laplace transform of L of t, so we are using a one formula, minus infinite to infinite e power minus at f of t into dt. This kind of a formula I will tell you. Okay, but when the things will come, then I will tell you, because we are learning here network. If you want to go for a Laplace, so it's a very detailed chapter, so I will tell you in maths. Okay, for now just understood, the step function Laplace transform is 1 by s, and here delay function is coming, that's why we are getting whatever the a value will be there, so this will be add here, so e power minus at into u of t, so we are getting 1 divided by s plus 1. Okay, and I told you about the conversion of a capacitor. So we already seen the how the capacitor is converted, and here the initial condition is 0, so no voltage, no extra voltage will get added, no initial condition will get added. Here also no extra initial condition will get added, so we are getting directly 1 by 2s, 5s, 5 2. Now this is your z1, this is your z2. This z1 is in series and this z2 is also in series, so z1 value you will get 2 plus 1 by 2s, so after solving this you will get 4s plus 1 by 2s, and z2 value you will get 5 plus 5s, so 5 plus 5s you are getting. Overall z will be z1 into z2 divided by z1 plus z2. So we did the calculation and we get the value of a z equivalent, 4s plus 1 into 5 plus 5s. Okay, and the overall z value is coming like this. And what will be the current? We got our z value, means our circuit is like this, positive negative 1 by s plus 1. This is my z, and the value is this. And if I want to find the current I of s, this is your v of s. So I of s is equals to v of s divided by z. I'm writing in z of s. So we did it. I of s is equals to v of s divided by z of s, and we get the result like this, 10s square plus 14s plus 5, because this s plus 1 and 4s plus 1 and 5 I will take common, so s plus 1 the whole square will come. Up to here it is clear, guys? Up to here it is clear?
Yes, sir.
Now in a integrations you have learned, I think, by parts. I think you have learned. Okay, so if you want to convert, means you have to break this form like this. as is equals to take like this, a naught divided by s plus 1 the whole square plus a1 divided by s plus 1 plus a2 divided by 4s plus 1. I'm taking, if you will take the LCM now, you will get the same things in a denominator. Okay, and I am assuming this terms like a constant term, so you need to find the value of a naught, a1, a2, a naught, a1, a2. Okay, so by solving a by parts, you will get the value of a0, a1, a2. How you will do these things? How you will do this particular thing by parts thing? So I hope you remember your basic maths. a0 s plus 1 into 4s plus 1 will come here. a1 s plus 1 uh, sorry, if you will take the LCM, you will get a0 into 4s plus 1 plus a1 into s plus 1 into 4s plus 1 plus a2 into s plus 1 the whole square. Okay, and so you are getting a 4 a0 s plus a0, and solve this one. a1 s plus 1 into 4s plus 1 plus a2 into s plus 1 the whole square. If you will solve this, and if you will equate with 10s square plus 14s plus 1, means if you will solve this, you will get some s square term here, some s term here, and some constant term here. So from this you have to equate this, from this you have to equate this. So you will get 2-3 equations. By solving this 2-3 equation, you will get the value of a0, a1, a2. a0, a1, a2 value you will get. Okay, a0, a1, a2 value you will get, and that value will come 1, 2, minus 2. So I am not solving here because we have to discuss these things in a maths. Okay, so if you want to solve, you can solve this circuit. You can equate this particular equation with this equation. You will get in the form of a01 plus a02, and you will get the value of a0, a1, a2. Okay, and if you will get the value of a0, a1, a2, now write, and actually we have taken 1 by 5 as a common. Okay, we are solving for this 10s square plus 14s plus 1 divided by s plus 1 the whole square plus 4s plus 1. So we are solving for this, so we will equate with this particular term. Okay, so you will get the terms like this: 1 by 5 s plus 1 the whole square plus 2 by 5 s plus 1 the whole s plus 1, and a2 will be minus 1 divided by 1 by 5. Here 2 by 3 will come, and here minus 2 by 3 will come. Some value a0, a1, a2 value you will get. So a1 value 1 by 5 you will get, sorry I have written wrong here, and a2 value you will get 2 by 3, and a3 value you will get 2 by 3. Just solve this equation and get the answer. A0 means any way you will get the answer of a0, a1, a2, and you have to put in the form like this. And after solving, so I am giving you one brief idea. What is the Laplace transform of a tu of t, ramp function? What is the Laplace transform of a ramp function? Tu of t Laplace transform is 1 by s square. Okay, if you are getting e power minus a t t into u of t, this will become 1 divided by s plus a the whole square. Okay, so here 1 by 5 is coming, so it's okay, and s plus 1 term is there, So that means 1 plus 1 is coming. It means e power minus t, and this is the function of a t. So t, that's it, and you have to give u of t. And what it will be, 2 by 3, 1 by s plus 1, I already told you, e power minus t. And here it was 4s plus 1. So 4s plus 1. Okay. So take 4 common, minus 1 by 12, s plus 1 by 4 you will get. Okay. So now this will be minus 1 by 12, and 1 by 4 is coming. So e power minus 1 by 4t u of t. You will get the result like this. Two was there, na? To function 2 was there. 2 was there. Okay. Let me give you one idea. So just write down some basic formula for Laplace transform. Laplace transform formula. Just write it down. U of t transformation is one by s. T u of t transformation is 1 upon s square. Sin at transformation is a divided by s square plus a square. Cos at transformation is s divided by s square plus a square. Okay. And e power at u of t, it will be 1 divided by s minus a. Means whatever the sign is there, so opposite sign will come. Okay. E power minus at u of t, it will be 1 by s plus a. E power at into t u of t, you will get 1 divided by s minus a the whole square. E power minus at into t u of t, it will be 1 divided by s plus a the whole square. If e power, just assume whatever the sign is coming, opposite sign will come. E power minus at sine, I am writing bt here, so it will be b divided by, original function is like this. Okay. So b divided by s square plus b square should come, but here delay is there, that's why s plus a the whole square is coming plus b square. Same thing, e power minus at to cos bt. So what will be the answer? Original function is this, but we are getting so s square plus b square, s should come, but here delay function is there. Because of that delay function, it will be s plus a divided by s plus a the whole square plus b square. Priyanka, understood this formula?
Yes, sir. Yeah.
Understood? You understood this formula, right? So,
Yes, sir. Yeah.
so just wait. So if you understood, means this is the basic Laplace transform formula. U of t is 1 by s, t u of t. Okay. Yeah. One last question. You have a circuit like this. Okay. question. Yes, this particular is your circuit. This is your 2 ohm. This particular is your positive negative 12 volt, and the switch was connected to 1, and this is your capacitor 1 by 400 farad. Now this switch we are moving to position 2. Just wait. So we are moving this switch, so position 2 at t is equals to 0. Okay, and this is your 1 Henry inductor, and this particular is positive negative v naught of t. So by Laplace transform, if you want to solve this question, so how you will solve? Because see, the combination is inductor and capacitor and inductor, so you cannot do with the normal method. So here you have to take the help of the Laplace transform. Okay, so find the value of a VC 0 minus first. So VC 0 minus will be your circuit at before t less than 0 was, this was your circuit, positive negative 12 volt, and this particular, it was your circuit for t less than 0. So what will be the VC 0 minus? This will become open circuit, and you will get the VC 0 minus is 12 only. So you are having a VC 0 minus is 12 volt. Okay, now after t greater than 0, what circuit you are getting? What circuit you are getting after t greater than 0? And your I0 minus will be 0 only. I0 minus will be inductor current, IL0 minus will be 0, because it was not having at 0 conditions any source. So this was 0 because it is connected to this, so there was a no current. So there I have a 1 Henry, and this is my V naught of t, positive negative, and the value of this R value is 10. This is 10, and this, the value of a capacitor is, it is 1 by 400 farad. Okay, so now convert this circuit in Laplace domain. So you remember, if the initial condition will be given, it will be 1 by Cs, and we will get positive negative V of 0 by S, V of 0 by S, and this, there is a no initial condition, so I am writing directly Ls, and this is R, this particular is R, and for finding the value of a positive negative, this V naught of S, I am assuming here as a V naught of S. So how you will get the V naught of S value? V naught of S, if you want to find, yeah, you can easily get this is V naught C, means capacitor value. So if you will substitute the value, overall value, so 1 by C value is 1 by 400, so it will go upside, so 400 by S will come. Okay, and positive negative V0 we got as a 12 by S, and this is your L value is 1 only, so it is S, and the resistance value is 10. So I need to find if I will get the value of I, means I of S current, if I will get, so if I multiply this and this, I will get the value of V naught of S. So So for now, what I am taking, I am assuming something here as a v1 of s. If I am assuming like a nodal analysis, simply I am doing the nodal analysis. So v1 of s minus 12 by s divided by this is your resistance only, because we are representing in the form of 1 by cs. So 400 by s only. Okay, plus v1 of s by s. Okay, plus v1 of s by 10. It will be 0 only. So if you will solve this particular circuit, what you will get, take the LCM, means s v1 of s will go upside, it will become 12 by 400 plus v1 of s by s plus v1 of s by 10, it is 0. Take the v1 part, v1 of s as a common, you will get s by 400 plus 1 by s plus 1 by 10, and take this part that side, you will get 12 by 400. Solve this v1 of s, you will get 400 as a LCM, and you are getting here as a s square term, and here it will be 400 term, plus here what term will come, this is 10, this is 10, so 40s will come, 40s will come, this is 12 by 400 will get cancelled out. So v1 of s you will get 12s divided by s square plus 400, write like this, 40s plus 400. So you are getting the value of a v1 of s, but what you need to find the v1 of s value na, only positive negative voltage across this. So this is your value, and you need to find it in the form of v1 of t. So how you will do, here s term is here particular s term is here, so make it in the form of a plus b the whole square. So 2 into 20. So how can you make it 2 into 20, a plus b the whole square? So write like this, v1 of s 12s divided by s plus 20 the whole square.
20 the whole square.
Yeah, s plus 20 the whole square only come. So s square plus 20 into 240, and 20 square will be 400, right?
Yeah.
So okay, now what you have to do plus 20 and do minus 20. Okay, if we'll do plus 20 and minus 20, what will happen, v1 of s will be 12 into s plus 20 divided by s plus 20 the whole square, minus 20 into 12 divided by s plus 20 the whole square. So s plus 20 and this will get cancelled out. So v1 of s you are getting 12 divided by s plus 20, and it is coming 12 to the 240 divided by s plus 20 the whole square. What is the inverse Laplace transform of this? v1 of t is 12 e power minus 20
20t.
u of t minus 240 t e power minus 20 t. Why t came? Because of the square, right? And here u of t will be there. So this is the v1 of t value. I hope you got this. Priyanka, understood? Priyanka, understood?
Yes, sir.
So what we did, this is not a very difficult question, it's a very easy question. I just see this, just see this part from here. We learned the Laplace transform, means like uh, here v of t is there, I of t is there, so we just know the basics, okay. And the inductor representation is like, if you want to represent the inductor, if you want to represent the inductor, so you are getting the inductor representation like this, ls into minus l of I0. If you want to represent the capacitor, so capacitor representation is like this, okay. And we find the value of a vc 0 minus is 12 only, and il of 0 minus is 0 value. So no need to represent your current source and or whatever the voltage source in this, because the initial conditions you are getting 0, but in a vc 0 minus you are getting a 12 volt, so you have to represent like this 12 by s, because we see the basics. And by applying this we can use the nodal analysis, and by using the nodal analysis only, v1 of s minus 12 by s divided by 400 by s, v1 of s by s into v1 of s by 10, I'm solving this particular network, solutions, and I'm getting this kind of a equation, 12s divided by s square plus 40s plus 400. But I cannot solve this equation in this form, so I am having this particular things. I know this is s plus a the whole square form, so s plus 20 the whole square, s square plus 40 s plus 400 only. Now I also don't know the Laplace transform of this 12s divided by s plus 20 the whole square, because one s is coming and plus is there, so I have to make it like this, okay, 20 minus 20, and separate it to and 12 is multiplied in both conditions, so 12 into s plus 20 minus 20 into 12. Now one power will get cancelled out, and here it will be remain, so 12 divided by s plus 20 and minus 240 divided by s plus 20 the whole square. And I told you the basic Laplace transformation, u of t is 1 by s, t u of t is 1 by s square, sin a t is a divided by s square plus a square. Here what was there, what was the formula we used there, e power minus at into t u of t, that is 1 by s plus a the whole square, s plus a the whole square. So 1 by t into e power minus 20 t u of t, this formula we used. And we will see this formula when I will teach you the maths, okay. In maths, this formula, maths also, in a signal system also, these things will repeated, okay. Priyanka, understood? You have to try by yourself, then only you will get it, okay. Try by yourself, means whatever the derivation I taught you today na, this particular derivation, see the lecture again and again and try these things by yourself, because everything is there, right. And I had said you so many times one things, I had repeated the concept so many times, so means still you are facing any doubt, you can ask. Priyanka, is this clear?
Yes, sir.
Okay. And yeah, so this was the story of Laplace transform, what we did today. This was the story of the Laplace transform. Now we are moving for a resonance circuit. So half an hour is there, we'll just see the what is resonance. So what is the meaning of resonance? What is the meaning of a resonance? See, when you have a resistor, when you have a inductor, and when you have a capacitor, these two value are out of phase. One at an angle 90 degree and one at an angle minus 90 degree. Okay. If I am giving this 5J, and this value I am talking about in terms of a XL value, and I am talking about in terms of XC value, and this is 5 at an angle minus 90 degree, when we will add r plus jxl minus jxc, when your xl is equals to xc, this will get 0. Although if you will, yeah, okay, so means what, you are getting a pure register, although inductor and capacitors are present there. So the balancing these twos are balancing and cancelling each other at particular frequency, at particular value. Okay, so this is known as resonance. Why we are saying the particular frequency? Because we are saying that xl is becoming xc, and xl value is 1 by omega l, and xc value is 1 sorry, xl value is omega l, xl value is omega l, and xc value is 1 by omega c. So what are the value for omega you are getting? Omega square is equals to 1 by lc, and omega value is getting your 1 by root under lc, 1 by root under lc. At this frequency na, at this particular frequency, if you will put the value of a omega, this is what, this is your frequency only. Omega is what? Omega is 2 pi f. Omega is 2 pi f, 1 by root under lc. So frequency is what? 1 by 2 pi root under lc. This is your frequency. And when you are substituting this value in xl or xc, this will get cancelled out. This particular frequency is known as resonance frequency. Okay, Prasanna, is this clear?
Yes, sir.
So please watch the means what the topics you had missed today, please watch it, okay, because it was very
Yes,
important.
sir.
So for the occurrence of a resonance, I am writing, for the occurrence of resonance in the system, two energies are required, and in electrical network, these two energies are provided by the inductor and capacitor, in the form of magnetic field and electrical field energy. In the form of magnetic field and electrical field energy, and electric field energy, okay, respectively. So the circuit is said to be resonance when the source voltage and the source current are in phase. Okay, write it down. In phase means whatever the voltage, suppose V at an angle theta is there, and if you are getting the I at an angle theta, means your V and I are on the same phase, your circuit will be in resonance, means there will be a no phase difference. The difference of angle between V and I will be 0. So you can also say the circuit is said to be a resonance when the source voltage and source current are in phase. Okay, and the resonance frequency indicates the rate at which the energy transformation take place between the inductor and capacitor. Write it down. The resonant frequency indicate the rate at which energy transformation takes place between the inductor and capacitor between inductor and capacitor. So suppose you have particular RLC network, R network, positive, negative, VR voltage, and you have L network, positive, negative, VL value, and you have a capacitor network, so it will have a voltage of a positive, negative, VC. Okay, so capacitor, it will have a voltage of positive, negative, VC. So this particular, it's having a voltage P and the current I'm getting as what I'm saying, as you remember, this is VC. So VL will be at an angle 90 degree and VC will be at an angle minus 90 degree. I hope you remember these things what we had discussed. And what I am saying, the magnitude of VL will be same as magnitude of VC. So that is I into XL is equals to I into XC. Okay, I into XL is equals to I into XC. So this I will get cancel out and you will get XL is equals to XC. And what is the meaning? XL is, I am taking omega naught as my resonant frequency. I am denoting like this. Omega naught L is equals to 1 by omega naught C. So omega naught square you will get 1 by LC. And omega naught value you will get 1 upon root under LC. It will mean radian per second. And if you want to take like this, F naught is equals to 2 pi, because omega naught is 2 pi F.
2 pi F.
So F naught will be
Under root
2
LC.
pi root under. Let's say this will be in hertz. Right. Now write the first condition. Mod Z versus omega. So Z is R plus J XL minus XC. So Z is R plus J omega L minus 1 by omega C. And mod Z value will be root under R square plus omega L minus 1 by omega C the whole square. Okay. So this is your mod Z value. Okay. This I am telling, this particular is your omega naught value. Okay. Here at z minimum will be r only. When your omega l is equals to omega c, you will get the minimum value. When there will be a difference, when there will be an anything difference, means negative difference, positive difference, so this value will be greater. When here when omega l is greater than omega c, and this position is denoting, oh sorry, yeah, this particular position is denoting your omega l
Omega L
is lesser than
less than omega C.
omega c, and this will be omega l is greater than
Will be greater.
omega c. Okay, so if omega l is lesser than omega c, means you are getting positive function, right? Or one thing means I'm just get confused. Let just give me a 2 second. It won't be like this. Just give me 1 second. Let me think. Okay, the function is like this. Here I am getting a leading graph. Okay, and here this is your lagging graph. Okay, leading na capacitor xc is greater than xl. Okay, always remember, because we are talking the leading lagging concept in terms of current and voltage. Okay, so in leading xc should be greater than xl, and in lagging xl should be greater than xc. So I wrote correct only. Okay, I wrote correct only. So this was in this particular your omega c. I wrote first correct only. Omega c is greater than omega l, and this particular your omega l is greater than omega c. So this is actually your RC network, and this is your RL network. Okay, because RC network will give you a leading power factor, and RL network will give you a lagging power factor. Is this clear? Leading, lagging, and even if you are writing lagging here and leading here, so it will be means if you are writing a lagging here, so you have to write omega l is greater than omega c here, and if you are writing a leading here, you have to write omega l is greater than omega c is greater than omega l, and this will become RC network, this will become RL network. It's just a representation. Okay, but this is the ideal representation. We write leading first and then lagging first, and in that case omega c is greater than omega l if it is a leading, because when you will get the power factor, leading power factor, when we have a capacitor, RC capacitor, means your capacitive effect is greater than your inductive effect, so that's why omega c is greater than omega l. And when we are getting the lagging power factor, when your inductive effect is greater than capacitive effect, that's why we are getting omega l is greater than omega l. And at that point, this particular point, you are getting a unity power factor. Oh, not unity. See, you are getting r plus j0, right? R plus j0. So tan inverse 0 by r, you are getting 0, and cos 0 is 1 only. Yeah, you will get unity power factor, UPF, at this particular point. This is your ideal graph. Practical graph should be like this. Like this. This is the practical graph. Is this clear, guys? Prasanna, understood?
Yes, sir.
Now the second graph is x versus omega. So x is what? X is xl minus xc. and x is omega L minus 1 by omega c. So suppose I have a graph like this. This is my omega and this is my x. Okay. So this was my omega naught value. So at omega naught value, xl is equals to xc, right? At omega naught value, xl is equals to xc, so you will get 0. Your x value you will get 0 at omega naught. Okay. And suppose this is your this particular I am drawing a line for. This is my xl line, and suppose I am drawing this particular, it's my xc line, minus xc line. So at this point, this xl is equals to magnitude of this xl is equals to magnitude of this xc. So that's why it's getting cancelled out. And we are getting basically what xl minus xc. Some xl value is this and some xc value is this. So we are subtracting this value from this value. So the subtraction will be subtraction of this from this. It will results like this. It will get reduced result. This is your x value you will get. Okay. So now it is done. Now just go for your I versus omega graph. Last graph. That is the last graph. I versus omega graph. So I is what? Guys, V is equals to I into R, or basically we are talking about the impedance circuit, so we are writing V is equals to I into Z. So I is equals to V upon Z, and I is equals to V divided by root under R square plus XL minus XC the whole square. So if I want to make the graph, this is my omega and this is my omega naught, and this is my I function. So at what value I will get the maximum value? When your XL minus XC value is 0. Means, and this is possible at omega naught frequency only. So that's why if something is less, if V is divided by something less, you will get I maximum value. Okay, so the curve will be like this. Here you will get I max value. That is, and this value is 0. So that means what? V by R you are getting directly. And again the same concept, leading will come, then lagging will come. Means this is XC greater than XL, and here XL is greater than XC. Is this clear? Prasanna, Priyanka, is this clear?
Yeah.
So, see, we are not remembering anything. We are just analyzing the things. Okay? We are just analyzing the things. There is no need to remember anything. Okay? Now, another graph. That is phi versus omega naught. Omega. not omega naught, omega. So first case I am assuming when omega is less than omega naught, some value, some my resonant frequency value is lesser than this omega value. So in that case what will happen, you know, see the cases, see the cases. This is omega, means it's the value is coming particularly here. When I am talking about omega is lesser than omega naught, so it is lesser than omega naught, so value is coming here, it means it is leading, it is leading case, it is leading case. And in leading case, which is greater? Xc is greater than XL, Xc is greater than XL. So that means what? You are getting Z is equals to R minus JX, particularly negative will come, right? So this is what? This is your RC network, RC network. So in RC network, I hope you remember, current leads by angle phi, power factor leading. Guys, is this clear? Prasanna understood? If you are having any
Yeah.
doubt you can ask here only. See, okay, now means we are moving like this. We got the graph now. We were having a omega naught. If you are seeing a z function, so this was my RC network, and this is the omega value. Overall is the omega value. I'm talking about omega is lesser than omega naught. So this is RC network only, and in RC network, XC is greater than XL. So Z is R plus J XL minus XC. If this XC is greater than XL, you will get negative. So that's why negative came. Okay. And if you will go for at omega is equals to, if I am saying at omega is equals to omega naught, so at omega is equals to omega naught, so my XL is XC, XL was coming to XC, so that means what? Z will be equal to R, purely resistive. What we are getting? Purely resistive. And I hope you guys remember, in a resistance gate, what? Voltage and current will be in phase.
In phase.
So that's what we did. It is in phase. And the third case is when omega value is greater than omega naught, means it's exceeding this value. This was omega naught, it's exceeding this value, means we are talking about this particular any frequency after this omega naught. So this was your RL network, and in this case XL will be greater than XC, so Z will be equal to R plus JX. And in inductive case, your voltage will lead and current will lag by angle phi. Okay guys, so if you want to draw this particular graph, you can draw like this. You can draw like this. Okay. लिखेंगे इसको थोड़ा सा, जस्ट वेट. Okay, so this particular value is your the graph will be between plus 90 to minus 90 only. So if it is plus 90 means 0 to plus 90 case means your phi angle is 0 to 90 degree. That means we are talking about leading. Okay, if it is between 0 to minus angle is coming, that means we are talking about lagging. This is your omega function and this is your phi. Okay, so and at omega naught, when it will be 0 degree, the phi will be 0 means you are getting the purely resistive, right? So the graph will come like this. Okay, so from this particular to this, so this is, in this case, if it is, this is your leading case, that means xc is greater than xl, and this is your omega naught means x is equals to 0 and z is equals to r, and this particular is your xl is greater than
Excel is greater than
xc, and this is your
lagging.
Okay, so this particular is your leading part, this particular is your leading part, and this particular is your lagging part. Is this clear? Means 0 to 90 degree you will get leading, and 0 to minus 90 degree you will get lagging, and at 0 degree you will get omega naught is equals to x is equals to 0. When phi will be 0? At omega naught frequency. Guys, is this clear?
So,
Okay. So yeah, we'll discuss tomorrow the rest of the topics, because I have to give you the some statement regarding this graph, so I will give you tomorrow only. And I had given you all the things for this part, and in tomorrow resonance circuit will be over, and yeah, tomorrow only the resonance circuit will get over, and we will start. Okay.
sir, send the video recording links
Yeah, I will upload it.
if possible.
Okay. Yeah, tomorrow only we will start the graph theory. Please Prasanna, watch that Laplace video. It's very important. Okay.
Yeah, sure, sure.
So I will upload it now only, and I will means within 1 hour, I will send you the link in a group.
Yeah, okay.
Okay. So good night, guys. We'll meet tomorrow.
Okay.